first one's going to be pretty straightforward and quick. We already looked at ones like this. I'll go back to a function that's like the one we had earlier. A little different, 3x squared minus 4x plus 7. Okay, and I want to know what is the limit as x goes to 2 of f of x. Okay, now before you say, oh, plug in 2.01 and 2.0001, remember that's a last resort. By the way, you probably don't want your first option to be plugging in 5 values on the right and 5 values on the left. That's pretty tedious. Okay, remember, if you can plug in the value of a at the beginning, go ahead and do it. Are there any domain issues? Okay, so you might want to ask, what is the domain of this function? Okay, this is quadratic, so the domain is all real numbers. That means you should not have any problems plugging in 2. So go ahead and do it. 3 times 2 squared minus 4 times 2 plus 7. Remember all those rules we talked about? That's why I can plug in 2 into this first term with the 3 that's a constant out front, and the square, by the way. That's like 3 different rules going on there at once, but we don't usually think about that as 3 different rules. It's just kind of plug in 2, right? Plug in 2 into the middle one. The last one's a constant. I'm almost using every single rule that we talked about at the beginning just within this one problem, even though it feels like all I did was plug in 2 everywhere. Okay, so those rules are needed to know that we're allowed to do that, but once we do that, we don't really think too much about that within this context. So go ahead and just use your order of operations here carefully. Okay, 3 times 4 is 12, minus 4 times 2, okay, so minus 8 and plus 7. Let's see, 12 minus 8 and 4 plus 7, you should get 11. Okay, and if you were to look at the graph of this function, f of x, as x is getting close to 2, y, the output would be getting really close to 11. In fact, I'm guessing there is a point on this graph that is the point 2 comma 11. Okay, so if you can plug in a value, go ahead and do it. Okay, in one of the previous videos, we had this function, f of x equals x minus 1 over x squared minus 1. And we wanted to know what is the limit as x goes to 1. In fact, you might even remember what we got from a previous video. Okay, and so let's see, I'm just going to write the limit as x goes to 1 of f of x. Okay, can you plug in the value of 1? Okay, remember that's kind of our first method, our first thing we want to try. But it turns out if we can't actually plug in 1, if we try to plug in 1 for x, what we get is a 0 on the top and a 0 on the bottom. By the way, just a side note, 0 divided by 0 is what we're going to call an indeterminate form. We'll see that down the road. For those of you thinking that 0 divided by 0 is 0, no, it's not always. For those of you thinking, oh, you can't divide by 0, so that doesn't make any sense, we'll see that you can actually do that down the road. So it's not just automatically undefined, or it's not automatically infinity. And for those of you maybe thinking, oh yeah, there's some, like you have some rule that says any number divided by itself is supposed to be 1. That doesn't really work when you're talking about 0 over 0. So we don't really have a way to be able to deal with that other than, or at least we don't have a way to deal with that by plugging in a value. But remember, what do we do if we can't plug in a value? Try to simplify, okay? So think about how you can simplify this function. Well, you could go ahead and factor. Factor on the bottom, factors as x plus 1, x minus 1. There's the difference of 2 squares. Now you have an x minus 1 on top and on bottom. And so this whole thing is really the same thing as the limit as x goes to 1 of 1 over x plus 1. And so now that we've simplified by factoring and canceling on top and on bottom, now we go back to method number 1 that says, can you plug that value in? Okay. Oh, yes, we can actually. We can plug in x equals 1, and we get 1 over 1 plus 1. That's 1 over 2. We get a half. Okay, and if you remember in one of the last videos, we plugged in decimal values that were close to 1, and we got like 0.499, 0.49999, 0.49999, whatever, and we were like, oh, that's probably 0.5. This is a little better way to know that we get something like a half or 0.5 instead of having to test a bunch of values on the right side and on the left side just to get a decimal that we hope is close. Let's look at a kind of a different kind of problem where we can still simplify, but it might not be one that you've seen as much of. Okay, so let me make sure I have it here. So let's look at this. We have something like the limit as t goes to 0 of the square root of t squared plus 9 minus 3 all over t. Okay, so if I said to try to simplify this thing, based on what we did in the last problem, some of you might try to factor this, but because of this square root, we really can't factor this or do a lot with this. Okay, and by the way, this is where your algebra skills come in. This is why in order to be successful in calculus, you really have to have strong algebra skills. Okay, if your algebra skills are weak, there are a lot of problems throughout the semester where you could really struggle. So that being said, do you remember something back from your algebra classes called a conjugate? Okay, and specifically this conjugate is going to deal with something that has a square root in it. And here's what a conjugate looks like. It says take the same terms that you have, so the square root of t squared plus 9 and the 3, but change the sign that's in between them. So instead of a minus in between them, it's going to be a plus in between them. Now, I'm going to multiply by that conjugate on top and on bottom. And this is a good strategy every time that you have a square root problem, or at least I should say 95% of the time you have a square root problem that you're trying to find a limit for. So this is a good one to kind of have in your back pocket and say, when I see a limit with a square root problem, this might be a good strategy to use. Okay, and so notice what I'm multiplying here. I'm multiplying by some fancy form of 1, perfectly legal. That's always allowed to multiply by 1. Okay, but look at what happens when you multiply by this square root of t squared plus 9 plus 3, both on top and on bottom. Okay, go ahead and look at the top first. Go ahead and FOIL this. This is one binomial on the left, another binomial on the right. When you FOIL these out here, okay, the square root of t squared plus 9 times the square root of t squared plus 9 just gives you t squared plus 9. And then you're going to have a plus 3 square root of t squared plus 9 and a minus 3 square root of t squared plus 9. And then on the very end, you're going to have a minus 9. Now this is why we chose to use a conjugate in the first place, is if you look at these two terms in the middle, they cancel each other out. And you're just left with a t squared plus 9 minus 9. So I tell you what, let me go ahead and I'm just going to erase this since these cancel each other out. I get to cheat a little bit on a tablet here. Okay, there we go. And so we have something like this. Okay, so by the way, we have a t squared plus 9 minus 9, and then the plus 9 and minus 9 cancel. Okay, now on the bottom, I'm just going to leave it as t and then times the square root of t squared plus 9 plus 3. Just go ahead and throw that whole thing in parentheses. And we still need to make sure that we have this limit as t goes to 0 out front. The more limit problems we do, sometimes people tend to forget the limit out in front. Please don't forget that limit. Okay, that's got to come along for the ride. It's got to be in every step that you're right there. Okay, so now what we have is we can do some algebra, and remember the goal was to simplify. We're kind of using method 2 here. We couldn't plug in a value of 0. Did we even check that at the beginning, by the way? I don't know if we did. Try to plug in 0 at the very beginning. Okay, 0 for t. You would be dividing by 0 right there, and then if you plug in 0 on the top, you actually get 0 as well, because you would get the square root of 9, which is 3, minus 3, and so you get 0 on the top also. So I don't know that we checked that earlier, but we should have tried it, because we should be trying method number 1, and then if we can't use method number 1, then go to method 2. So we're on method 2 now. We're trying to simplify this thing, and what we have left is just t squared on top, and we can have one of those t's cancel with one of the ones on the bottom, and what we're left with is something like the limit as t goes to 0. We just have a t left on top, and that's it. And then on the bottom, we have a square root of t squared plus 9 plus 3. Kind of running out of space a little bit here. And so now you should ask, okay, now that I've tried to simplify, now that I've actually canceled some stuff, I've canceled the 9 and the minus 9 on top, and I canceled the t with the t on the bottom, could I plug in 0 for t? Is that okay now at this point? Okay, look at what happens when you plug in 0 for t on the top. You get 0. Okay, what happens when you plug in t for or 0 for t on the bottom? Okay, is that allowed? So you get 0 plus 9 inside the square root. You get the square root of 9, which is 3, and then plus 3, you actually get 6. Okay, and so is that okay? Yes, it is. Okay, and by the way, it's okay to have 0 on the top. That's 0, not a problem. And so this is a way that we could handle something with a square root in it. Okay. So just something to keep in mind, this is another way that we can simplify a problem, even if it doesn't mean factoring and then canceling. All right, let's take a look at one more. Do a little practice in here. So, okay, I should mention, we've actually already seen a few examples in the last video about how to apply method 3, right, is plug in values that are really close. So if you can't simplify, then go ahead and try to use that method number 3. But we've already done some of those, so I'm not going to walk through a lot of those. Here is a problem that we could have from the beginning. The limit as h goes to 0 of 3 plus h squared minus 9 all over h. Okay, so again, you should be thinking about kind of what are your options? What methods could you try? What could you do to try to find this limit? So equals what? That's what we want to know. Okay, so based on our criteria or what we've had as our methods so far, hopefully you should be thinking about what would you want to do first. Okay, the first thing you should try is try to plug in 0 for h. Let's see what happens if you plug in 0 for h. Okay. If you plug in 0 for h, you should get something like 3 plus 0 squared minus 9 all over 0, which the fact that you have a 0 on the bottom, that's already going to be a problem anyways, but then 9 minus 9 on the top, you're going to get 0 over 0. And again, remember, 0 over 0 is not necessarily 0. It's not necessarily undefined. It's not 1. We don't know how to deal with that. We're going to see that more down the road, but for now, we should think about, do we have a way to be able to simplify? Because clearly we get this problem if we try to plug in a value. And so right when you see 0 over 0, for now you should say, wait a second, no problem, I don't know what to do with that. Okay, so let's go back to the original. Can we use method number 2 then? Can we try to simplify that? Okay, so go ahead and try that on your own as I walk through this. You can kind of walk through this with me. The limit as h goes to 0. Let's see, if you square 3 plus h, by the way, this is a calculus course. Please never let me catch you taking the square and bringing it into the 3 and into the h. That is not how you square that. That is the same thing as 3 plus h times 3 plus h. Okay, FOIL that out. That is 9 plus 6h plus h squared. Okay, you'll know better than that at this point. All right, and so you get something like this. Well, then you have a plus 9 and a minus 9 that cancel on the top. And what you should have left at this point is the limit as h goes to 0 of 6h plus h squared all over h. And you can factor an h out of the top. Okay, so factor an h out of the top, and you're left with a 6 plus h. And the h on the top can cancel with the h on the bottom. And you're left with the limit as h goes to 0 of 6 plus h. Well, notice at no point in these steps, you could try it, go back and check every one of these steps, at no point in these steps could you have plugged in 0 for h. Okay, but at the very end, where you have the limit as h goes to 0 of just 6 plus h, now there's no more h on the bottom. You could actually plug in 0 for h, and you would just get 6 as your answer. Okay, so go ahead and simplify if you're not able to plug in a value. And then after that, if all else fails and you have a really weird function that you don't know what to do with still, you can't simplify things any further, then if you're really stuck, you could use that method number 3, like we did in the last video a couple of times. Plug in values really, really close. Just make sure you plug in values from the left side and from the right.